All right, I've built a yield model for corn. I also built one for soybeans. I'm not done with it yet. It'll surface on agweather.com when I get it finished. Many of you probably know this inherently, but I'm going to give you the actual number. 59% of the ability for a corn crop to produce a high yield is dependent on temperature. I used to think that drought controlled everything. It does not. 59% of what controls the yield are temperatures, primarily during silking and grain fill. That's it. Do you know that the corn plant, honestly, if you just look statistically at how it grows, we think that a lot of things matter early in the season. They do, but they do not matter nearly as much as one critical 3-week time period in July and then how things shape out in August. That's all this shows. The model that I built, I used 4 different machine learning techniques to figure this out. They all gave us the same similar answers. I said, well, what do we need to know about how corn grows? This is the most important figure that I'm going to give you today. Look at it. I built a model using 171 different feature engineering factors about weather to try to correlate them against yield. That is nerd speak for. I spent my time and did my homework and found out that there are 6 primary things that matter most. Everything after this is not in the noise, but not nearly as impactful. Watch me animate the screen. Top left, maximum temperatures during silking. Max temperatures during silking, but you need to know how hot. Because on each graph, what you're going to see is yield going down in the negative y direction, yield going up this way. If you look at that, it turns out that 95 degrees Fahrenheit during silking is the first break point that if you get hotter than that, you start to lose some yield. You go past 97, and it is just a cascade downward because that crop stops using the energy it's putting in to transport sugars into a kernel and starts using it to stay alive. I think you all know this. You also need to have your grain fill temperatures, okay, look something like this. Crop does best in August when it's not blazing hot. If it gets hot in August, then you've got some problems, and you can lose yield quickly. You can go from a +6 to a -6 in terms of yield just by shifting the temperatures 8 degrees Fahrenheit in the month of August. What about the maximum temperature in July? That's the third most important. If you see me forecasting temperatures that are 4 degrees warmer than normal in July, or you get up there to 6 degrees warmer than July, that's worth 8 bushel off the crop. 8 degrees warmer is worth 10. 10 degrees warmer is worth 15. That's the secret right there. Temperatures all across the top. Now, what's the next ones? Silking, precipitation during silking. Oh, the crop says 5 inches is perfect. Give me 5 inches during silking. What about precipitation in June? Well, 4 to 6 is perfect. 2.5 is too little. 7.5 is too much. Get your minds out of the gutter, some of you right now, okay? I'm not this is rainfall that we're talking about here, okay? But this is it. That's what it wants. It just wants this perfect amount. Now I got you all your minds in the gutter. Sorry about that. And then look over there at precipitation in June. Oh, I'm so sorry. So sorry. Let's click through this real quick. Precipitation in June. We don't want a super wet crop in June. Your corn actually thrives on just a hint of drought stress in June, but not the last week of June. The last week of June is when we start to have some problems. So what are the predictors for summer? If it's not El Nino, and it's not looking for the planets to align and all the other garbage that some of you pay subscription prices to get from some of these people that sell you these things, what is it? It's right here. When you look at that, the number one predictor of July heat in the Corn Belt is your spring soil moisture. You're going, wait a minute, you said heat, but you talk about moisture. Yep, watch the box over there on the right. You got to watch this spot right here. Specifically, right in the middle of it in Graceland. If that area goes over really, really dry in June, we tend to have problems in the I-states. So I just say this, if Elvis is dry and there's drought in his front yard, we've got a problem. That's going to be it. Now you're going, well, why does moisture impact heat? Because of the way the sun works, which is also a sphere. We don't have individual suns, each of us. There's just one. It's our nearest star. It's extremely steady. My son's worried about it blowing up. I keep telling him, like, no, well, 5 billion years from now, yes. But you're not going to be around for it. Just don't worry about the dumb thing. Anyways, what you need to know is this. That sun beats down on the surface of the earth. And if you've got water in the vegetation and you've got water in the soil, guess what? 50% of its energy goes into just evaporating the water. If there is no water, 50% of it goes into sensibly heating the ground. And if that gets hot, guess what it also does? Any additional moisture? Gone. It just evaporates it really quickly. You've got to have moisture inside of that weird squiggly thing that I've drawn there, which kind of hugs the Appalachian Mountains on one side, the plateau over in Texas on the other, and then the western dry plains. That's the key thing to look out for. So knowing that, I think it'd be a good idea, like, well, let's just take a look at where we are. That's current soil moisture down to 16 inches. I'm worried about the eastern Corn Belt today because of all of this. The northern half of my state, eastern Iowa, southern Wisconsin, parts of northern Indiana, Ohio, Michigan, we have gone over quite dry, missing a lot of the recent rains. But Elvis's front lawn looks pretty good.